in today's video, we are going to transform a standard EKS deployment into a secure production-ready environment using the NGINX Ingress controller and certificate manager. So with the increasing need for secure web application, understanding how to automate SSL certificate management is crucial for any DevOps professional or cloud engineer. So we'll start by setting up our EKS cluster, then we'll move on to installing the NGINX Ingress controller, and finally we'll automate SSL certificate provisioning with the help of certificate manager or cert-manager. Before we dive in, make sure you have an AWS account ready, and the following tools are required for this tutorial. So first up, we'll be requiring AWS CLI, then we'll be requiring kubectl, and we'll be also requiring EKSCTL. So if you need any help with this, check the link in the description. So I'll be adding the installation step for each of these one. If you find this video helpful, don't forget to like and subscribe for more cloud tutorials. So let's get started. Now let's jump into the first step. So the first step will be setting up our AWS EKS cluster. So as I mentioned, today I'll be using EKSCTL. So earlier on in my video, we had used Terraform to create EKS cluster. So EKSCTL is ideal for users who need a quick and easy way to set up and manage EKS cluster without delving deep into the complexities of infrastructure as a code. And Terraform is suitable for those users who require a comprehensive and flexible tool to manage a wide range of infrastructure resources across multiple cloud providers, including EKS cluster. So ultimately, the choice between EKSCTL and Terraform depends on your specific need. So as of now, today I'll be using EKSCTL to create my cluster. So if you see, I have my AWS install. So usage AWS. So if I show you AWS configure, I already have my access keys and secret keys in place. So the region that I'll be currently working on will be AWS region, North Virginia region, that is US East 1. I have Helm installed on my device, so the one that I'm referring to. And also it requires EKSCTL, so I also have EKSCTL installed on my device. So using EKSCTL create, so we'll be creating resources that will be EKS resources, and also I have kubectl installed, so you will also be requiring kubectl to be on your device. So kubectl controls the Kubernetes cluster manager. So in order to interact with the Kubernetes cluster, we'll be requiring CLI interface or CLI tool. So kubectl will be the utility that we'll be using. So without further ado, so let's start. So I'll be using EKSCTL command, create a cluster. So create, and we'll want to create a cluster, and I'll give name to my cluster. So it will be EKS. Okay, so I'll be giving name as EKS SSL, and as I mentioned, I'll be using region US East 1. So this will be North Virginia region, and I also do need to provide my node group name, EKS SSL node group. And other than this, we also need to give the node type. So for this node type, I'll be using t2.small, or I'll be using t3.small. And the node we are trying to create a managed node, so managed nodes. And the node count, I think we do need to provide node count, so I think I'll be providing with 2 nodes for this creation. So let's see. Okay, so you can see it's creating the resources. So if I go to my AWS console, so here let me go to CloudFormation. So here we can see EKS SSL cluster. So this is in progress. So yeah, so description, if you see EKS cluster dedicated VPC, so it will be creating VPC for our networking. So our cluster will be requiring AWS network. So for that it creates VPC, then it also creates IAM user, and as we can see, we are using EKSCTL to create the cluster and node group. So created and managed by EKS. So if I go and check the description for this one, so we can see the events that it's performing for now. So here we can see creating in progress. So for, as I mentioned, so it creates a VPC. So for VPC, it's creating the internet gateway, creating NAT IP service role, and so on. So it's also creating security groups and subnet, public subnet, private subnet accordingly, and so on. So there are lots of other things that goes behind when creating the cluster, created as a stack within the CloudFormation. So as I said, it becomes easy to create EKS cluster within the AWS, as it is a CLI provided by AWS itself. So let's wait for some time until the cluster and the node gets created, and we'll be continuing further. Okay, so the cluster and node groups are created accordingly. So let's go to AWS console and check if they are created successfully or not. So let me go to stacks once, and we can see EKS SSL cluster is created. So the status, we can see creation complete, and accordingly we have the node group, EKS SSL node group as well. So it's also created successfully. So let's go to this and check for the event. So here we can see the control plane creation is completed, and as I showed earlier as well, so lots of other resources are created within AWS, and we have managed node as well, so that got created. and we can see we are using launch template, so that was t3.small, so based on which the cluster and the node group got created. So this is the Docker image that we'll be using. So this is uploaded by Alex Wayne, so we'll be using this one. Okay, so let's go back to our VS Code and let's continue from here. So before this, what I'll do is I'll also add this on our readme file so that anyone who will follow this will be able to follow along with this. Okay, so the cluster is created successfully, so I need to update the cluster context. So now I'll be updating the config file in .cube folder to connect to the cluster. So the current cluster that I created was, so if you see, the name was EKS SSL, so we need to provide context accordingly. So AWS EKS update cube config, and my region that I created was US East 1, and the name of my cluster is EKS-SSL. Okay, so here I need to provide region flag and only the region name. Okay, so here we can see added new context ARN. So this is the cluster name and this is added to my .cube config. So as I mentioned, we'll be using NGINX Ingress Helm repository, so we need to add that. So talking about it, we need to add the repository because it allows us to access the official NGINX Ingress controller chart for the installation. The utility of using this is it provides the necessary resources to deploy the Ingress controller using Helm. So let me go back here and let's see Ingress NGINX controller. So let me go back here and let me add this. So Helm repo add. So I'll be giving this a name. So this will be Ingress NGINX itself. And let me do one thing. Let me copy this from here and I'll be adding this. And I think I won't be requiring this. NGINX, okay. Okay, as you can see, Ingress NGINX already exists with the same configuration is keeping. So let me see once Helm ls. Okay, so there are no releases, but we can see there is a repo already there. So Helm repo ls. Okay, so we can see Ingress NGINX stp kubernetes.github.io/Ingress NGINX is already added, and so we added the NGINX Ingress Helm repository to our machine. So we need to install the NGINX Ingress controller to manage external access to the service within the Kubernetes cluster, routing HTTP traffic to the appropriate service. So it acts as a gateway for the external traffic, providing load balancing, SSL termination, and routing capabilities. So for this, I have command here. So I'll be copying this and I'll be adding this here. Okay, so I'll be installing the chart using the above command. So here we can see release Ingress NGINX does not exist, installing it now. So this will be installing the NGINX Ingress charts, and then we'll be installing cert-manager for this. So this might take some time. Let's wait until it gets created. And as we can see, AWS load balancer type is set to NLB. So this will be creating a network load balancer for us. So if we can see an example of Ingress that makes the use of the controller. So the controller is added, but we haven't utilized this. So for this, we'll be requiring Ingress controller. So I already have manifest file written for this. So during the deployment, we'll be checking this, what we are doing and everything like that. So this will be as it is. So let me clear this. And let's go to our AWS console and let's check if the load balancer is created or not. So let me go here and let's check. So here we can see a load balancer is created, but the state is on provisioning. So to utilize this, we'll need to wait for some time until the state or the state gets on running state or created state accordingly. So here we can see our namespace with Ingress NGINX is created, and the age is 2 minutes and 1 second. So kubectl get all within this namespace. So that will be my Ingress -NG, sorry, NGINX, and we can see our resources created within this namespace. So we have this pod, and we have service, and this is the external IP or the DNS name for the load balancer. So A756, let's verify A756. So this is the same one that got created using this one. So let me clear this and we are good to go. Now we'll be installing cert-manager. So for cert-manager, if you see, I have this cert-manager -cert-manager GitHub release page which is created. So let me go back to VS Code and I'll be utilizing that itself. So kubectl apply -f, and let me copy this one itself. So as you can see, there are multiple releases available here. So this is the latest one, but this is pre-release. So I'll be using a stable version for this one. So I might use this one. So version 1.15.3 releases slash and my okay download slash, this is the version that I'm using. So this is the latest release, and cert-manager dot crds.yaml. So these are the custom resource definition. So custom resource definition are required for certificate manager to define custom resources like certificate and issue. So this is not provided by Kubernetes by default. So we need to add our custom resource definition to utilize this. And using this, it enables certificate manager to manage SSL certificate as Kubernetes resources itself. Let me first show you the deployment.yaml file and other file first, and we will be installing this accordingly. Okay, so here we can see the API version is set to apps version 1, the kind is deployment, and the metadata name is set as game app, and the app.kubernetes name is set as app. So this will be requiring to match the label. So currently the replica set is set to 2, so I'll be selecting it as 5. So we are using this image. So as I showed earlier, so this is the Docker image that I'll be using. So lxmine docker 2048 is the Docker image, and image pull policy is set to always, and the container port that it will be listening on is port 80. Okay, so far so good. And also I'd like to show the service for this one. So the service, as we can see, it's created as type node port. So if you see type, it determines how service is export, and valid options for our service type will be external name, cluster IP, node port, and load balancer. So the node port builds on cluster IP and allocates support on every node which routes to the cluster IP. So this is the allowed values, and currently we have set it as node port. Okay, so far so good. Now let me do one thing. So let me apply this deployment and kubectl apply deployment.yml, and I'll also be applying the service.yml. So as you see, I haven't used any namespace, so this will be created on the default namespace. Okay, so let's see if it got created or not, the pod game app. So this was the name that we provided, so based on which this game app is created. I think I didn't save the deployment after changing it to replica 5. So the earlier it was set to 2, so accordingly it's creating only 2 replicas. So let me save this and let me again deploy the deployment.yml. So now it will be creating 5 replica for us. Okay, so game app unchanged. Okay, so here we can see 1, 2, 3, 4, and 5. So 5 pods are created, and so on. So this is the service that we created, and this is the deployment. So this deployment defined that we require the replica or the pod to be of count 5. So based on which 5 pods are created. So here is the replica set, here is the deployment, and here is the service, and these are the pods created based on this. So far so good. Now let me go to my AWS Route 53. So as I said, we'll be requiring Route 53 for routing the traffic to our domain name. So on my hosted zone, we can see there is a domain CloudCast Nepal. So for this one, I'll be adding a record. So let me close this and let me create a record for this one. So let me add kubernetes.cloudcastnepal.com, and it will be routing to my endpoint. So it will be my network load balancer, and my region I selected was US East 1. So let me go to US East 1. So this is the region and the load balancer that was created. So A756 was the earlier one that got created. So I'm selecting this one and I'm creating the record. So the domain portion is also completed. So as I said earlier, so I downloaded the cert-manager custom resource definition. So now I'll be installing the manager itself. So this will be the certificate manager. So the same version I'm using. So this is the latest one. So as we can see, it created lots of resources. Okay, so as we can see, it's creating almost multiple resources. So it's creating service account, it's creating role-based authentication for authorization. So it's also binding the role-based authorization to cert-manager controller and so on. So here we can see it created deployment and service files accordingly. So these are all the resources that got created accordingly, and let's clear this. Now let's check the port it created, cert-manager. Okay, so I think I added this extra flag here. Okay, so here we can see we have created 3. So this one is for certificate injector, and this is the webhook, and this is the certificate manager pod accordingly. So we also deployed our application. So the deployment YAML, as I mentioned earlier, so it defined the desired state of our application. So earlier it was 2, so based on which it created 2 pods, and currently we set it as 5, so it created 5 accordingly. And the major role of this one or this deployment file is to ensure our application is running and can scale as needed. So whenever we set the replica as 5, so whenever required, it automatically scales based on the capacity that's or the traffic. And also I showed you the service.yml. So the main role of service is to expose our application to other services even within the cluster, and also to the Ingress controller for external access. And so using this, it provides us an stable endpoint for accessing our application and abstracting the underlying pod. Now the question that we have is we need to configure the DNS and SSL. So I went to DNS Route 53 record and created the DNS name accordingly. So here you can see there is a cluster issuer. So this configuration tells the certificate manager that we just created on how to obtain the SSL certificate from Let's Encrypt. So as you all know, if you have already used Let's Encrypt, it requires an email address. So this needs to be a valid email address. So I'm adding my own email address. And let me save this. Okay, so let me apply this. So kubectl apply -f cluster issuer.yml. So this will be applying the cluster issuer. Okay, so this got created accordingly. And now the final piece that we need to add is this controller. So for this we need to provide the domain or the host so that it will be redirected. So if its request coming from this domain will be passed on to this Ingress controller, and then it gets routed to the internal service accordingly. So the domain name that I just created, kubernetes.cloudcastnepal.com. Let me copy this. We also need to provide this here as well for the TLS. So we define the Ingress resource with SSL configuration, and this resource specifies how external traffic should be routed to our service and includes the SSL setting as well. So let me save this and let's go back here and let's apply this as well. Okay, so here we can say annotation Kubernetes Ingress class is depreciated. Please use specification.ingress class name instead of this one. So regardless of this, the resource is created. So now let me go back to my Safari and let's try and access this. So Kuber, I think I have just copied that. So let me paste it here and let's try to access. Okay, so we can see our complete website is ready, and here we can see Safari is using an encrypted connection to kubernetes.cloudcastnepal.com. So encryption with a digital certificate keeps information private as it's sent to or from the HTTPS website Kubernetes. So here we can see the certificate. So it was issued by R11 and it expires on next January 2025. And here we can see this certificate is valid. So if we see other details as well. So accordingly, it was created by Let's Encrypt. So this was the common name that we provided, and so on. So yes, accordingly, we can see our application is ready and hosted. So this is a get. So in this way, we can set up our production level application and make it functional and secure it using SSL and TLS certificates. This is how we can transform a standard EKS deployment into a secure production ready environment using the NGINX Ingress controller and certificate